Okay, so let's do an example of a hypothesis test for a mean. Okay, so here we've taken 15 data points and we're trying to find if the average is less than 500. You can read about the details if you like. Okay, so here, setting up the hypothesis, very important. Here, less, that is not less than or equal, it's just less than. So here, mu, the average, is less than 500. That would be in the alternative. There is no equal sign here. Okay, or the null is just mu is equal to 500. Finding the test statistic. First of all, I know this is a t-test because I don't have any sort of idea what the population standard deviation is. All I can do is estimate it by finding the sample standard deviation. I have S, not sigma. Okay, so here's the formula. Then the actual average, you've got some readout here. We could actually put this data into minitab and find the average if we wanted to. Somebody's already found it for us. 386. Subtract the hypothesized value, that is 500. Divided by S, again, somebody's found that for us. Here is S. And divided by root of n. Okay, this is our test statistic. Again, very good idea to draw the picture. Here's our test statistic. It's negative 1.5. Test statistics can be negative or positive. Okay, so the middle is 0. Here on the negative side is negative 1.58. Okay, so that's fine. And the p-value, of course, is on the same side that the alternative hypothesis points to. The p-value is just a one tail here. Okay, so here then I would find degree of freedom. My sample size is 15, so 15 minus 1 is 14. And my t-table, I'd go down to the 14th row. What I'm looking for here is 1.58. I'm looking for 1.58 and not negative 1.58 simply because the t-table is only based on positive values. Okay, so here I'm just going to ignore the negative just because my t-table only gives me positive values. So here then I find 1.345 and 1.761. I know that this point is somewhere in between there. Therefore, my p-value is somewhere in between here and here. Okay, so here the p-value is somewhere in between 5 and 10%, somewhere in between these 2 points. Okay, it's not equal to 5%. It's not equal, sorry, not 10. I've got a typo here. This should be 0.1, not 0.01. Okay, so it's somewhere in between 5 and 10%. Later I'll show you what minitab actually shows you what it is. But we can say that I know that it's not equal to 5%. I know that it's not equal to 10% because it wasn't exactly this value and it wasn't exactly this value. So these are not equal. It truly is in between these two. Based on this sample, then, we're 95% certain that the mean count of all those infected is here. We've got a p-value that is large. Okay, so somewhere in between 5 and 10. Which is larger than the alpha of 5, so somewhere in between 5 and 10. It's not equal to 5, it's somewhere in between greater than 5 and less than 10. So we will fail to reject the null hypothesis. Okay, so this is the idea that we are going with. We say the mean appears to be not significantly less than 500. So we are not going with this idea. This doesn't appear to be true. Mu does not appear to be less than 500, at least significantly. So the mean is not significantly less than 500. In minitab, how do you do this? Okay, here we go to stat basic stats, one sample t. Okay, I've got summarized data here in this case. My sample size is 15. My sample average was 386. The standard deviation was 279.2. And the hypothesized value was 500. I want to perform my hypothesis test, so I click on that, 500. The options here, my confidence level is 95, and my sign in the alternative is the less than sign. Here, this is the test statistic, and we knew that the p-value was somewhere in between 5 and 10. It actually happens to be 6.8%. Okay, and we've got an upper bound here of 513.